Okay, so my name is Denis Gundarev. I'm a program manager at the Remote Desktop Services Group here at Microsoft. I recently joined Microsoft this January, but I've been around in the community and in the industry for a while. I'm working on the Remote Desktop protocol itself with my fellow team members, and the goal of this session is to talk about the remote desktop protocol as it was, as it is right now, and what we do plan in the future and what we implement in the Windows 10 and the Windows Virtual Desktop. So remote desktop protocol, as you probably aware, many of you should be aware of this, was introduced back in 1998. So it's like 21 year old protocol that can drink probably if it would go to the bar in the US. The first version of the protocol was RDP version 4, so there was no version 3 or 2 or version 1 ever published. RDP version 4 was introduced in Windows NT4 Terminal Server Edition with codename Hydra. And the protocol was released as a part of operating system for almost all the time. Sometimes the updates were included in the service packs, but most of the updates were as part of the operating system. So if you need to use some new features, you have to upgrade to a new version of Windows. And that was our story for a long time. The RDP protocol is used for obviously remote desktop connections for remote app, and it also used for many other components like Hyper-V, console remoting, Windows Defender application guards, Windows Sandbox, some other components. And many people think that RDP is kind of outdated protocol, that it lacks some capabilities, but it is not true, actually. So many people that I've seen in the field, they still think that RDP is something that is very useful to manage the servers, but not useful for actual users connecting to the VDI desktops or published applications. So to break this myth, I want to just talk about the protocol evolution first, and I will start with RDP version 7, which was released with Windows 7 more than 10 years ago. That was a time when the remote app was added to the protocol. The RDP started supporting multi-monitor configuration, and the multi-monitor support for RDP that was introduced more than 10 years ago is the true multi-monitor support compared to some other protocols. It supports up to 16 monitors, and like nowadays it supports 4K monitors. I have 3 4K monitors plus 1 HD monitor on my desk, and when I remote to my remote desktops, everything works, and I can even watch videos. And with RDP, you can have different sizes, different shapes of the monitors. They can be arranged in a different way, so it's not just a line or monitors on top of each other. So in that times, the protocol added support for print redirection, and we had many updates after that. And the next update was with Service Pack for Windows 7 with RDP version 7.1 in 2009, 10 years ago, where the remote effects capabilities were added to the protocol. And the funny thing that that version, RDP version 7.9, was the last version that was supported by the free RDP project. And the free RDP project, as you may know, is heavily used to deliver the RDP experience to the Linux, including the thin clients. And the biggest problem with this, that most of the thin clients that do support RDP protocol that are using the Linux version of FreeRDP, they stuck with RDP version 7.1. They don't support all other features that were introduced after that, that were introduced with RDP 8, with Windows 8, when we added UDP support for the protocol as a transport, and we actually switched most of the remote graphics to the UDP. When we added progressive Callisto codec, where you deliver images with a low resolution, and then when those movements are stopped, when pictures on the screen are stopped, we update the picture with the high quality resolution. With RDP8, we added support for multi-touch. 8.1 added support for H.264 encoding based on the software, and in RDP 10 with Windows 10 in 2015, we added 444 chroma support for H.264, and we added pen remoting. We added clients for macOS, iOS, and Android. And after Windows 10, original Windows 10 release, we were releasing updates to the protocol with every Windows version that was released. With every semi-annual update, we're adding new functionality, and this process is ongoing. We added a lot of features. The most significant ones, I would say, are adding the video camera redirection, adding the support for 444 dynamic encoding, mixed mode encoding for H.264, when we remoting the video using the hardware encoders and the hardware decoders, but we add the missing chroma, missing color components to the image to ensure the high quality text, and we actually deliver the lossless, visually lossless text graphics with H.264, which is great, and we are able to use the hardware encoders, and we are not limited to one vendor. We're not using the NVENC directly or AMD encoder directly. We're using the MFT Media Foundation transforms in that designed for encoding and decoding of the graphics in Windows. And by using the MFT, we switched to MFT in Windows 10 release 1809, and since the switch, we are opening the road for ourselves to use other codecs that can be embedded to the Windows 10. We added support for URCP, which is a UDP-based protocol that it is designed for the low bandwidth and wide area networks, that is designed for wireless networks, and we are able to use the network more efficiently while still having the rest of the traffic for flowing without any interruptions. And we were adding new features. We added the multiple GPU encoding. If your server has multiple GPUs, and it doesn't matter all those GPUs are physical or you're using the virtual GPUs that are coming from your hypervisor, we can use multiple GPUs in the session, and we can load balance the graphics between those GPUs. We added support for that in the protocol and in Windows itself. We improved the video playback by better detecting the video and better detecting the graphics. We added support for AVC 444 for HTML5 client. We now, as I said, we're using Windows Media Foundation platform for our codecs, and this lets us to use other codecs in the future and without too much development work. As I said, we added support for Universal Rate Control Protocol that analyze the network better and use the all available bandwidth and adds the error correction to improve the quality. Some other minor improvements for print for remote printing. We added the camera redirection that redirect the cameras as a high-level device, and it's not a USB direction, which is not really efficient for the cameras. It's a camera device that is visible in your applications, no matter do you use Teams, you use WebEx, or you use any other application that use camera. This camera would be presented as a remote camera, and we do support 4K graphics. The graphics are encoded using H.264 video stream, and it's very efficient for in terms of use of the network. As I said, we added AVC 444 support, and this adds a little bit of overhead because we are sending additional data on top of the standard H.264 encoding, but we are getting better video support, and you can see, even if you have like subtitles on top of the video, you will see the quality of those subtitles would be much better than without AVC 444 support. We recently deprecated remote FX vGPUs, and there's a lot of requests coming that what is coming next. I will talk about this on the next slide. But what I want to highlight that remote FX is not supported only on Windows Server 2019 as a host OS, but it is still supported on Windows Server 2016. If you're dependent on remote FX, if your deployments use it, you can continue to use it until the end of the general support or until the end of the extended support for Windows Server 2016. So you have a lot of time while we are working on the replacement. So Windows Server 2019 doesn't have, I mean, technically has remote FX for the migration scenario, but it's not supported anymore, but you can continue to use Windows Server 2016. I want to highlight some things that are coming to replace the remote FX. We are working on two technologies. One is support for GPU partitioning on the hypervisor level. You will be able to work with partitioning that is available in the graphics cards from NVIDIA and from AMD. We do work on another technology that is called GPU virtualization, or we also call it GPU power virtualization. It's a technology that looks very similar to remote FX. You have a like fake virtual GPU inside the VM, but compared to remote FX, it's way different. With remote FX, we were trying to simulate all of the APIs, OpenGL APIs, DirectX APIs in the driver, and then pass it to the actual hardware. With WDM GPU virtualization, we are actually passing all of the capabilities of the GPU to the virtual machine, and you are able to use all of the APIs available. If you use NVIDIA cards, you will be able to use CUDA. If you use AMD, you will be able to use their specific APIs, and it doesn't. You will not be dependent on the Windows release cycles to get updates to support the newer versions of the codecs. We in Windows Virtual Desktop, we added a component called RDP side-by-side stack. RDP side-by-side stack is an installable protocol stack that is packaged as an MSI package, and it contains the whole RDP protocol, and it can be installed on Windows 10 to support Windows Virtual Desktop. It can be installed on previous versions of Windows. It can be installed on Windows 2016. It can be even installed on Windows 7. And effectively, when Windows Virtual Desktop would be released and we will have full support of Windows 7 on the Windows Virtual Desktop, Windows 7 would use RDP version 10.7, and you will be able to do the multiple pen remoting. You will be able to use H.264 as a codec, and all other capabilities are installed as a part of the RDP side-by-side stack. In recent release of Windows in 1903, we switched our graphic support to use WDDM-based display driver. We did it for many reasons, and some of them are internal. We want to retire the legacy XPDM driver that was around since Windows 2000. We are improving the performance, and with just switching to the newer graphics model, we are able to render more frames. Almost twice more frames per second can be rendered when we are deprecating the legacy XDDM driver. And we are working with our partners like Citrix and VMware to help them utilize the new driver model and make sure that they are able to use it efficiently. One of the upcoming features that we plan to release very soon is support for Teams redirection. The Microsoft Teams is the greatest ever messaging application, and we want our customers to have the greatest support for it on the Windows Virtual Desktop, and we adding this specific support to RDP protocol. We are also working on the technology that called RDP short pass that will let you optimize the network routing for the RDP protocol and use UDP connections without the gateway by traversing the net firewalls. We will better use Azure routing capabilities, and we will support the gateway discovery in multi-region in multiple regions. When users are migrating from one location to another, they will connect to a specific gateway that is closer to them. And I think that's it. I'm out of time. It's 20 minutes too short for me. Thank you.
Yeah. Hey, thanks, Denis. That's awesome. Yeah, this is great stuff. Ruben and I were chatting offline while you were speaking. Like, it would be really cool to get people in your position from the other protocol vendors as well involved in an event like this, because I think a lot of this is really, really good information.